Okay, the 10.3 quick check. Okay, we're starting off here. It says polarity. For each of the compounds, draw the Lewis dot structure, determine whether there are polar covalent bonds, predict whether the compound is polar, and then identify the intermolecular forces involved. Okay, so remember these four things, these are pretty important for us, that those four elements that are the strong nonmetals, we're going to need that. So first off, draw the Lewis dot structures. So here we have an H2S. So S we know has 6 dots. That means it can make 2 bonds, and it's going to make those bonds to the hydrogens. So our molecule looks like that. Okay, determine whether there are polar covalent bonds, S and H. Okay, S and H are both nonmetals, but they are not part of the strong nonmetals, so they're both weak. That means it's going to be a non-polar covalent bond. So polar covalent bonds, no. Okay, is it a polar molecule? Well, if it's non-polar bonds, then it can't be a polar molecule. Non-polar ones, that means this must be London dispersion forces. Okay, second one, we have CH4. Okay, so we know carbon has 4 dots. Okay, it's in family 4. That means it can make 4 bonds. So 4 bonds to the hydrogens. Okay, I kind of missed that one, but I'll try again. Dink. Yeah. Okay. There we go. Okay, and what happens is that a polar covalent bond, again, carbon and hydrogen, both, and neither one of those is a strong nonmetal. So again, that's a nonpolar covalent bond, so therefore that has to be nonpolar. But thinking about this on a test, okay, this guy here, that is a nonpolar sort of a shape. Those, if there were polar bonds, they would still cancel out. This one, okay, that's kind of a polar shape. If that was a polar bond, they would not cancel, and that would be a polar molecule. So, but in this case, nonpolar, nonpolar. So again, nonpolar, those are going to be London dispersion forces. Okay, we have NH3. Nitrogen has 5 valence electrons. Okay, that leaves 3 places to bond. We're going to bond to a hydrogen this way. We're going to bond to a hydrogen this way. And we're going to bond to a hydrogen this way. And that's our molecule. Okay, do they have polar covalent bonds? Yes. Okay, nitrogen is one of our strong nonmetals, and hydrogen's a weak, so that is going to be a polar covalent bond. Will they cancel? Okay, well, they could. You might say, well, this one and this one, they might cancel because they're across from each other, but there's nothing to cancel this one, so this is going to be a polar molecule. And again, other clues we said, if you see that lone pair on the central atom, like a nitrogen or an oxygen, that's probably going to make it polar. Okay? Didn't work in this case over here with the sulfur because the bond was not polar. But, the idea is that that's a indication of a polar molecule. So if we have a polar molecule, the question is it hydrogen bonding or dipole-dipole interactions? And we have N with H. Okay, when you see N with H, then we know that that is a hydrogen bonding. Okay, hydrogen bonding. Okay, second part. For each of the intermolecular forces, okay, we draw these structures. Okay, put a circle around one molecule. Okay, so I'm going to do that in red. I'll do that part first. So here is one little HCl. Okay, here we can pick up, there's one little water. And here is one CO2. That's the easy one. That's kind of easy to get. So there's a whole lot of places where you can draw that, but that's one answer. Okay, draw an arrow pointing to the bonds in the molecule. Okay, well, there's a bond right here between those two, and that bond is covalent bond. Every molecule, the bond in the molecule is covalent bond, and here that's going to be a covalent bond. Okay, so between the C's and the O's. And then draw a box around the IMF. Okay, well, the IMF is this dotted lines. Okay, and the IMF here are these dotted lines. And the IMFs here, that's these dotted lines. And they usually use dotted lines, so that's kind of a good indication. Now, what is the IMF? Okay, well, in this case, the first case here, we have a positive and negative. This is HCl, that's a polar molecule. So this is dipole-dipole interaction. And it's a polar molecule, and we have H, but we don't have N or F. So that's just a dipole-dipole. H2O, we have H with O, so that is a hydrogen bonding. And CO2, that's a nonpolar molecule. Okay, C double bond O, double bond O. Okay, that's a nonpolar molecule just because of the shape, and so that's going to be London dispersion forces. And that's the quick check.